Okay, welcome to the third module in EKG reading. This one's called Rate, Rhythm, and Axis. So let's first take a look at the EKG. At the top of every EKG, the computer usually does a read of a lot of different parameters, and it's going to do a much better job than I'm going to do. But it's still important to know how to do these things yourself. For example, calculating the rate, and then as well as the axis. We're looking specifically at the R-axis, so this number over here. Let's try to come up with those things ourselves, though. Another thing to note on the EKG are these numbers down here. You could see this, 25 millimeters per second. That means it's hard to see in here, but each one of these big boxes here represents 5 millimeters. So obviously 5 times 5 is 25, and that's a second. So I'm going to draw them in here quickly. So that's 5 millimeters. And let's put a couple more of these in to get a second's worth. So this is 1, 2, 3, 4, 5. This whole thing is worth 1 second of time here. 1 second. So how long is an EKG in total? Well, let's take a look. We already know what a second is here. But let's figure out the whole thing. So I'm going to make copies of these until we fill up the entire EKG. There, so that brings us to the end. Let's zoom out and see exactly how many of these we got. There. So, on this EKG we got 1 second, 2, 3, 4, 5, 6, 7, 8, 9, 10. The whole EKG is only 10 seconds long, given that you have 25 millimeters per second. These speeds can change, but for the most part it's set on that. Now let's calculate the rate. Before we do so, I want you to take a look at a couple of important numbers we want to remember. And these numbers are 300, 150, 100, 75, 60, and 50. I'll show you how to use these in a second. So we want to know what is the rate given these beats here. So let's try and find one of these QRS complexes that falls right on one of these lines. And I guess this one is pretty close, right? So we want to know where's the next one. It's right there. So let's count how many boxes that is. 1 box, 2, 3, 4, 5. So we're in between the 4th and the 5th. That's where that next beat falls. Okay, so now let's use those numbers. Those are going to help us. So this is 300. This is 150. 100. 75. So if the next beat fell here, it would be 300 beats per minute. If it was here, 150 beats per minute. Here 100 and here 75. So we are in between these two, so we're somewhere between 100 and 75, and we're closer to 75. So I would guess, if I were to look at this, I would estimate that this would be about 80 beats per minute. And if we look at what the computer calculated, we're pretty darn close. Look at that, 78, and we said 80. Pretty good. That's how you calculate rate. Now let's look at rhythm. The first thing I'm going to do is trace this waveform. So you got a P, usually there's a small Q, an R, an S, and then the T. And let's get another one. So P, small Q, R, S, T. Great. I'm going to move that over here. And let's label these waveforms. So this is the P. The first downward deflection is the Q. The next upward is the R, the first upward is the R, and the next downward is the S, and this one is the T. So again, we got P, Q, R, S, T. So what do these represent? I'm going to draw a picture of a heart to kind of put this into perspective. And that's the SA node. And this is the AV node. And let's draw this as the bundle of His, the left bundle, and the right bundle. The left bundle is actually, it does divide into two, but we'll talk about that in a future podcast. So the SA node is the pacemaker cell with the fastest rate in the heart, so it sets the rate of what's going to happen. So when this fires, it sends electrical activity through the heart, and both atria will contract. Obviously, the right side is going to contract before the left side, just because it's closer. Contraction of the atria results in the P. The next thing that's going to happen is it's going to hit the AV node. Now there's a built-in delay into the AV node, so it doesn't fire right away. But this AV node then fires, and then the signal goes down both of these bundles. And that allows the ventricles to depolarize, and that gives us the QRS. And then when they repolarize, that's the T. So whenever you have this kind of configuration, P, QRS, T, that's called normal sinus rhythm. Often abbreviated as NSR. So what would be not normal? Well, let's take a look at one of these. So if you had something like this, you can see here that this is a little different. There's no P here. There's no P here. But there is a QRS complex and a T. Again, there's no P. QRS, T. No P, no P. So this, without that standard P, QRS, T, is not normal sinus rhythm. We'll go over what this is in a future podcast. So that's how you determine rhythm. You look for the P, QRS, and T. Finally, let's look at axis. Now, in order to look at axis, we're going to want to use our axis system. So we had that hexaxial system, and it's always nice to take something that's at 90 degrees to each other. And we have two leads that are that way. There's F, which is positive when pointing down, and 1, which is positive when pointing here to the left. So obviously F is negative going up here, and 1 is negative going over here. So anything that is in this area here, in this quadrant, we're going to call normal axis. Anything that's in this quadrant is right axis. Anything that's way over here, this is extreme axis. And anything that's up here, well, this gets a little tricky actually. Anything that's up in this area, we're going to call left. And anything that's over here is still left axis. Okay, so how do we measure these axes? Let's look at the EKG. Now we decided that we were going to use as our, let's zoom out a little, axis system leads 1 and leads F. These are the ones that are going to be 90 degrees to each other. So let's plot some vectors on there. Let's go to 1. We want to see how positive this is. So let's start here. We're going to count how many of those little millimeter blocks there are. So let's use this as the baseline. So that's 0, 1, 2, 3, 4. So this is plus 4. Okay, and then how negative is it? Well, how much does it go below the baseline? That's 1, 2. That's minus 2 for a sum of positive 2. Let's go to our axes then and plot that. So we said that we are positive 2, 1, 2. Now let's see where we are on the F axis. Let's do a similar thing here. So this is 0, 1, 2, 3, 4, let's just say 5, plus 5, and then how negative? 0, 1, 2, 3, 4, minus 4, for a sum total of positive 1 on the f-axis. So let's go there and plot that. So there, positive 1. So our vector would go like that. And that falls within this normal quadrant. So what can we say about this? Anytime f is positive and 1 is positive, we're going to be within this normal quadrant. So if you have a positive 1 and positive f, you know you're going to have normal axis. Anytime that f is positive and 1 is negative, we know that we have right axis. Similarly, whenever f is negative and 1 is negative, we have an extreme axis. And finally, this quadrant is the quadrant wherever 1 is positive and f is negative. Well, two things could happen. We could either be left or we could be normal. Remember, this blue area is where it's normal. How do you tell where you are? Well, luckily, this little divider line is perpendicular to lead 2. So if that's positive 2, then we know that that's negative 2. Let's zoom in there. So anytime that we're on this side of that divider line, we know that we're along the positive 2 axis. So positive 2 gets us on this side of the divider line and in the normal axis zone. If 2 is negative, we know we're over here and in the left axis zone. So let's annotate this a bit. So if we're in this quadrant here, we know we got to look at lead 2. If lead 2 is positive, we have normal axis. If lead 2 is negative, we're on that other side and we have left axis. Given that 1 is positive and f is negative. So let's go look at lead 2 and see where we are. So here's lead 2. So we got 0, 1, 2, 3, 4, 5. Let's just say 6, plus 6. And here we got minus 1, minus 2, minus 3, minus 3. So positive 3 total. So 2 is positive. Two being positive, we know that we're probably on this side of the line and in the normal axis zone, which is exactly what we thought. So that's it. Rate, rhythm, and axis.